In this problem, water from an oil spill is leaking into a 10,000 gallon pool of water, and the contaminated water contains 1 gram of oil per gallon, and it's flowing in at a rate of 10 gallons per hour. At the other end of the swimming pool, we have water leaking out at 10 gallons per hour as well. So the total volume of water is going to remain constant over time, but the amount of oil in the pool is likely to change. So we're going to write a differential equation for the amount of oil in the pond at any time. Alright, so the first thing we need is a variable. Let's let capital A be the amount of oil in the pool. Let's see, and our units are grams. Okay, when we know that the amount of oil that we have is just going to be the amount that comes in minus the amount that goes out. Okay. So we're ready to talk about a differential equation now. What can we say about the rate of change, so dA over dt, the rate of change of oil? Well, the units are the first thing we can figure out. The units for A were grams, the units for T would be hours in this problem. So we know our units should be grams per hour. Okay, well, rereading the problem, we see that there was 1 gram of oil per 1 gallon of water. And we're going to need to multiply that by, we see 10 gallons per hour, so that would be 10 gallons per 1 hour, and the gallons will cancel, and that leaves us with grams per hour, which are the exact units for dA over dt. That's how we can check our work, make sure that what we're writing makes sense. All right, now what about the water that's leaving the pool? Well, once again, oops, I see 10 gallons per 1 hour, but what about the number of grams and the number of gallons here? Well, we assume that it mixes really well in the pool and that the water that's flowing out is representative of the composition for the entire pool. So we need to look at the whole pool. How many grams were in the entire pool? The answer is, A. A is the number of grams in the whole pool. How many gallons in the whole pool? Well, it was 10,000. And once again, the gallons cancel out, and we're left with grams per hour. So we get that dA over dt equals 10, and I won't write the units because they get in the way a little bit when we start doing the math, but 10 minus, and then got 1 over 1,000 times A. There's our differential equation. Okay, we need to learn how to solve differential equations like this. It's not terribly difficult, but for now we're just trying to set it up. Now, the next question up top was, what amount of the pond will be oil after a very long time? Okay, so how much oil will there be in the pond eventually? Well, is there some equilibrium value? To answer that, we look at our dA over dt expression here. If there's an equilibrium value, the slope would be 0. It wouldn't be changing anymore. So what would capital A have to be to give us 0 in our differential equation? And the answer there is 10,000. If A equals 10,000, you're going to get 10 minus 10. You'll get 0. So we could also plot the slope field here. So if I go up 10,000, the slope is 0. If there's less than 10,000, what we will find is that we're approaching 10,000 grams, and that's actually true whether we had more than 10,000 to start with or not. So the equilibrium amount of oil is 10,000 grams. And that limiting amount doesn't depend on how much was initially present.